When an AI seems brilliant for 5 minutes and then suddenly forgets something you clearly said earlier, that is not always the model being dumb. It is usually the model running out of working memory. In AI engineering, that working memory has a name, the context window. A context window is the amount of information a model can look at while generating an answer. Not everything it learned during training, not every conversation you have ever had, just the information currently placed in front of it. Think of it like one shared workspace. If the node is on the desk, the model can use it. If it falls off the desk, the model may act like it never existed. And this workspace is measured in tokens, not words. A token can be a word, part of a word, punctuation, white space, or a short phrase. Different models can tokenize the same text differently. As a rough mental shortcut, 1 million tokens is around 750,000 words, but do not treat that like a fixed exchange rate. Tokenization is closer to packing a suitcase than counting pages. What actually goes into the context window, your prompt, the conversation history, the model's draft response system instructions, you may never see uploaded files, retrieve chunks from a vector database, to results, even formatting and line breaks. So when an app says large context, remember every feature is competing for the same token budget. Large context is powerful. It can help a model summarize long documents, compare many sources, follow a project over multiple turns, or reason over code. That is why long context models feel like a big upgrade. They can keep more evidence on the desk at once. But bigger does not mean infinite, and it definitely does not mean perfect. Putting a whole library on the desk does not guarantee the model reads the exact paragraph you care about. Here is the deeper part. Most modern language models use transformers. Transformers rely on attention, which lets tokens relate to other tokens, but attention gets expensive. When the input gets longer, compute and latency can grow fast. A useful rule of thumb, doubling the sequence can mean roughly 4 times the attention work. So long context can improve capability, but it can also increase costs, slow responses, and add more noise. There is also a quality problem called loss in the middle. Models often use information better when it appears near the beginning or the end of a long prompt. Important details buried in the middle can be missed. This is why giant prompts sometimes produce weirdly generic answers. The model had the information, but the workspace was too crowded. Bigger context helps, clean context helps more. When the window gets full, an AI app has to make a choice. It can truncate old text, it can summarize earlier turns, it can keep the most recent messages, or it can use retrieval, also called rag, to search for relevant chunks and insert only what matters. This is the hidden engineering behind good AI products, not just prompting, but deciding what deserves to be in context right now. Practical checklist. Put the most important instruction near the end. Keep requirements explicit. Remove stale clutter when the task changes. For long documents, point to the exact section. Repeat key constraints when accuracy matters. And for serious apps, design a content strategy. Trim, summarize, retrieve, then answer. You are not annoying the AI, you are giving it a clean desk. Takeaway, a context window is the model's temporary workspace. It is measured in tokens. It controls how much information the model can consider at once. Long context is impressive. Clean context is engineering. Day 8, temperature versus topic. That is where we control whether the model sounds focused, creative, or completely chaotic. See you there.